What would you do if your phone signal had to travel 15 billion miles to get through? Voyager 1 doesn't have modern technology, and yet it still talks to us. How is this even possible? Let's unravel the mystery. NASA is still sending and receiving messages from a spacecraft launched over 40 years ago, running on technology that would look like a dinosaur next to our phones and laptops today. Voyager 1 took off in 1977, and while it's been traveling farther than any man-made object in history, what's on board is about as advanced as an old calculator. This is the challenge: maintaining connection with a spacecraft that's not only 15 billion miles away, but also operating on systems designed in the era of disco and rotary phones. Let's start with the basics. Voyager 1's onboard systems weren't cutting edge, even when it launched. The spacecraft communicates using a transmitter that outputs just 23 watts of power. To put it simply, that's less powerful than a household light bulb. Imagine trying to hear someone whisper from the other side of a football stadium, except the whisper is passing through a vacuum, across billions of miles, and has to dodge all kinds of background noise on its way. The challenge isn't just distance, it's the fact that these signals lose strength along the way. Here's where things get wild. Voyager. One's computer has a memory capacity of around 68 kilobytes. To give you some perspective, the typical smartphone in your pocket has over 1,000,000 times more memory. And yet, that tiny memory has been enough to handle everything the spacecraft needs to do. From collecting data about the farthest edges of the solar system to sending information back home, this primitive machine still gets the job done. But here's the catch. Because the technology is so basic, it relies entirely on commands sent from Earth to carry out its tasks. Radio waves are what make communication between Earth and Voyager possible. These waves travel at the speed of light, but they weaken over distance. This is called path loss. By the time a signal from Voyager 1 reaches Earth, it's immeasurably faint. It's almost like trying to spot a single firefly from the other side of a continent. The further away the source, the harder it is to detect the signal. And that firefly analogy doesn't even do justice to the signal strength NASA deals with here. We're talking about billionths of a watt when it finally reaches us. Cosmic noise from stars, radiation, and other galactic phenomena makes picking out Voyager's tiny signal even more of a challenge. So, how does NASA manage to hear Voyager 1 amidst all this chaos? That's where the Deep Space Network, or DSN, comes in. The DSN is a collection of massive radio antennas stationed around the world, in California, Spain, and Australia. These dishes are enormous. The largest measures 70 meters in diameter, roughly the size of a football field. But it's not just their size that matters. The key is their sensitivity. These antennas are equipped with ultra-sensitive receivers that can detect Voyager's faint signals, amplify them, and make them readable. It's as if the DSN gives NASA a giant supersonic ear capable of picking out the tiniest whisper in the loudest room. The DSN doesn't operate like some high-volume call center, though. Every piece of data Voyager sends takes over 20 hours to reach Earth, traveling at light speed. This means there's no instant feedback, no back-and-forth conversations. Imagine sending a text message to a friend and not getting a reply until the day after tomorrow, followed by waiting another day to confirm they got your response. That delay is something scientists deal with every time they interact with Voyager. The farther the spacecraft travels, the longer the delay grows. But before we get into that time lag, think about this. For NASA to even receive those whispers from Voyager and distinguish them from the cosmic background noise, everything has to go absolutely right. The antennas need precise alignment, and the receivers must process what's often described as the weakest signal humanity has ever persistently worked with. And yet, through all of this, the DSN has been the lifeline that keeps Voyager connected to its creators, operating like a cosmic-scale communication bridge. This blend of outdated technology on the spacecraft and cutting-edge engineering on the ground is what makes this connection work. On Voyager's end, it's like a relic of the past, frozen in time from the 1970s. While here on Earth, scientists use the most advanced tools available to make that relic continue to function. And as magnificent as the DSN is, that 20-hour delay in communication takes this puzzle to another level, where timing becomes as critical as the connection itself. When we talk to Voyager 1, we aren't just talking to a spacecraft. We're talking across time and space. Every message NASA sends to Voyager takes over 20 hours to get there, and any response from Voyager needs another 20 hours to make the journey back. That's a round trip of more than 40 hours just for a single exchange. By the time we hear from the spacecraft, the information it sends is already almost a day old, meaning that our connection with Voyager is more like peering into the past than having a real-time conversation. This delay is a result of Voyager 1's unimaginable distance. Right now, it's over 15 billion miles away, or more than 160 times the distance between Earth and the Sun. For context, light, the fastest thing in the universe, takes just over 8 minutes to travel from the Sun to Earth. But for signals traveling to or from Voyager, that journey stretches to almost an entire day. Imagine sending someone a text and not only waiting close to 20 hours for it to deliver, but needing another 20 for their reply to show up. Even the most patient among us would find time travel texting like that pretty surreal. NASA doesn't just hit send and hope for the best either. Communicating with Voyager requires careful planning. The time delay means NASA can't adjust commands on the fly if there's an unexpected issue. Engineers have to think far ahead, accounting for where Voyager will be nearly 2 days into the future and what tasks it's supposed to complete in that time. Every instruction sent has to be meaningful, calculated, and timed with precision, because there's so little room for error. This isn't like controlling a drone or even a Mars rover, where delays are minutes or less. The consequences of that delay have shaped every aspect of how we interact with Voyager. Let's put this kind of interaction into perspective. If you've ever had to wait for a lagging video call to catch up, you know how frustrating even a few seconds of delay can feel. Now, multiply that inconvenience by thousands of times. Yet, somehow, NASA manages it. For example, when Voyager's cameras were turned off to save power decades ago, that wasn't done casually. Power conservation and strategic decisions like that were made with the understanding that these time gaps would only grow worse as the spacecraft continued its journey. In a way, years of preparation went into building a system designed to communicate with something so distant it's practically in another era. What makes this system even more incredible is Voyager's need to operate with some level of independence. Given the communication delay, it was built with autonomy in mind. Voyager 1 can't wait 40 hours for a response when it encounters an unexpected situation. That's where pre-programmed commands come into play. Before launching, engineers coded sets of instructions that Voyager could execute without needing Earth's input in real time. Think of it as a playlist of actions loaded into the spacecraft, ready to play even when there's radio silence. These commands cover essential tasks like reorienting the spacecraft's antenna toward Earth or protecting itself if something unusual happens. For instance, if Voyager detects a problem with its systems, it can trigger safety protocols on its own, from putting itself into a protective mode to switching to backup components. Voyager 1's faint, decades-old signals remind us just how far human curiosity and engineering can take us. Built with 1970s technology, this spacecraft continues to expand our understanding of the universe, defying the limits of distance and time. Its journey is proof that no frontier is truly unreachable when determination guides us. As technology evolves, one question lingers. What will we explore next? Whether it's distant stars, new planets, or deeper mysteries of space, Voyager inspires us to keep listening, keep exploring, and keep pushing boundaries. After all, even the faintest whispers from space carry the loudest messages about human potential.